Today we are going to be moving on to the next lesson, lesson 11.7. So in this lesson, we're going to be using some problem-solving strategies to solve for the area of rectangles and to look for patterns to compare how changing one measurement affects changing the overall area. So follow along as I unlock the problem. Mr. Coy wants to build storage buildings, so he drew plans for the buildings. He wants to know how the areas of the buildings are related. How does the area change from the area of building A to the area of building B? And how does the area change from the area of building C to the area of building D? Now, what we're going to use to solve for this is a table down here at the bottom. I need to keep our videos short, so we're going to just do some of the most crucial parts to this. So building A has a length of 3 feet and a width of 4 feet. And we know that to find the area, if I multiply the length times the width, 3 times 4, my area is 12 square feet. Now building B, the length is 3 feet, but the width is now 8 feet. 8 feet is twice as long as 4 feet. So if we're going to talk about how it compares, if I kept the length the same, but I made it twice as wide, it should mean that our area is going to be twice as big. That would fit the pattern. So let's see. 3 times 8 is 24 square feet, and 24 is twice the size of 12. Let's do it again with building C and building D. So the length of building C is 6 feet. The width is 4 feet. Now, 6 times 4 is an area of 24 square feet. On building D, the length is still 6 feet, but the width is now 8 feet. So if our pattern holds true, because the width is twice the size of the length, because I doubled the width, sorry about that, guys. The length stayed the same. I doubled the width. Then 6 times 8 is 48 square feet. And 48 is twice the size of 24. So, moving on to page 664. If you want to do another one to practice this problem, you would do the same way. Here you have E and F that keep the same length, but the width changes. Down here you have G and H that keep the same length, but the width is cut in half. So for some practice, you can fill in this chart and see if you cut the width in half, does that cut the area in half? If it follows the pattern, that should be true. Moving on. Many pools come in rectangular shapes. How do the areas of swimming pools change when the widths change? So here we have 4 swimming pools, and they are all 8 feet in length. But I see the width is going up by 10s. So let's see what happens to the area. Now, if I'm going to multiply length times width, I know that 8 times 2 is 16, and because this is a 20, I'm going to put a 0 behind it. So my area of pool A would be 160 square feet. B, the length is still 8, but now I'm going to multiply it by 30. So 8 times 3 is 24, plus the 0 because I multiplied by 30. So when I made this go up by 10, my area went up by 80. Okay. 8 times 40. Well, this went up by 10 again. 8 times 4 is 32. Add that 0. Okay, my area went up another 80. 8 times 50. 8 times 5 is 40. Plus that 0. 320 to 400, that's another plus 80. So every time I added another 10 feet in width, I added another 80 in square feet to the area. So let's think why that might be true. Well, adding another 10 feet of width means I added another 10 rows of 8. If you think of it like an array, I added another 10 rows of 8. And 10 times 8 is 80. So every time my width went up by 10, I added another 10 rows of 8, and my area went up by 80. So let's predict. If I did 8 times 60, and I followed this pattern, that would mean I know 400 plus 80 is 480. Well, let's see. 8 times 6 is 48. Plus that 0. Yep, the pattern holds true. So, let's do one of the word problems back here. A diagram of Paula's bedroom I'm doing number 5, is at the right. Her bedroom is in the shape of a rectangle. Write the measurements for the other sides. What is the perimeter of the room? There's a hint. 2 pairs of opposite sides are equal lengths. That's the definition of a rectangle. Opposite sides are equal in length. So that means since this side is opposite that side, it would also have to be 17 feet. And since this side is opposite that side, it would also have to be 12 feet. So, to find your perimeter, you would have to add 12 plus 17 plus 12 plus 17. Now, since this is a 12 plus 17, and that's a 12 plus 17, that means that if I do 12 plus 17 once and get 29, since that's another 12 plus 17, I can add another 29 for a total of 58. Now remember, this is perimeter, so it's just going to be 58 feet. And my answer would be the perimeter is 58 feet. All right. So you have some practice problems available if you want to go back over things. You have back here on page 664, you have another set of table that you could fill in. You have some other practice problems with some word problems if someone wants to help you with them. But your assignment is going to be doing a lesson and homework, practice and homework lesson 11.7.